So let's complete emulsion today. So emulsion are the biphasic liquid dosage forms. The biphasic liquid dosage form are of three types. One is emulsion, one is suspension, and one is colloid. In emulsion you will see liquid dispersions, and in suspension you will see solid liquid dispersion, and again in colloid you will see two types of phases. One is hydrophilic, one is hydrophobic. Hydrophilic will show again emulsion, and hydrophobic will show suspension. Okay, this liquid dispersion and solid liquid dispersion, what does it means? It means in the emulsion and suspension there are two phases. In one phase you will see solid, and other phase you will see liquid. That is called disperse phase, and that is called dispersion medium. So disperse phase will be dispersed inside the dispersion medium in the case of both the biphasic dosage form. But if both the phases are liquid, that means biphasic liquid dosage form, then it is called emulsion. And if one phase is solid, another phase is liquid, then it is called suspension. So in suspension you will see one phase, that is disperse phase is solid and dispersion medium is liquid. Whereas in the case of emulsion you will see disperse phase is also liquid, dispersion medium is also liquid. That's why emulsion is called liquid dispersion and suspension is called solid liquid dispersion. Am I clear? Next we will see that emulsions are the biphasic liquid dosage form, and they are thermodynamically unstable. They are thermodynamically unstable, consisting at least two immiscible liquid phases. One phase is called dispersion medium and the other one is called disperse phase. Okay. Now emulsions are stabilized by adding or addition of surface acting agent, surfactants, emulsifying agents, gums, emulgents, interfacial active agents. Okay, so see, this is a container. In these two different phases are there. So one is continuous phase. This continuous phase means it is dispersion medium, and one is discontinuous phase. That discontinuous phase is disperse phase. Okay, so one is disperse phase and one is dispersion medium. So this disperse phase will be dispersed inside the dispersion medium. Okay, so next example of immiscible phases are water and oil. So water is not miscible with oil. So by adding surfactants or any types of surface acting agent, we can increase little bit the solubility. Okay, next we will see the emulsifying agents. So emulsifying agents have two portions. Emulsifying agent have two portions. One is head part and one is tail part. So this head part is hydrophilic. This head part is having head H, and H is means hydrophilic. By this way you can remember, normally head part is hydrophilic because it is polar, and tail part is lipophilic because it is non-polar. So since it is non-polar, it is also lipophilic, and this the angle between the two bond in tail is 120 degree. This angle between the two bond is 120 degree. Okay, now see, so head part is polar, tail part is non-polar. According to Natta, the bond angle is 120 degree. So which bond angle? The bonds which are present on the tail. See, this is the carbon-carbon covalent bonds. Okay, and the tail has 120 degree angle. Okay, next, association of surfactants. So when surfactants will be associated, what will happen? Micelle will form, and the size of the micelle will be 5 to 100 nanometer. The size of the micelle will be 5 to 100 nanometer. 1 nanometer equals to 10 angstrom, and 50 to 1000 angstrom means 5 to 100 nanometer. Okay, so this is, see, this is a surface acting agent. In this part is the lipophilic part, and that part is the hydrophilic part. Okay, now hydrophilic surfactant. In the hydrophilic surfactant you will see the head is large, and in the lipophilic surfactant you will see the tail is large. Okay, so when long tail of surfactant is there, it is lipophilic, and when large head is there, it is hydrophilic. So why it is lipophilic? Due to the presence of large tail soluble with the lipophilic phase. So soluble with the lipid, so it is called lipid phase. And due to the presence of large head, it is soluble in water part or water phase, and that's why it is called hydrophilic. Okay, next we will see the dispersions. So number one is molecular dispersion, then colloidal dispersion, then coarse dispersion. These are based on the size of the particles. So when the size of the particle is less than 1 nanometer, when the size of the particle is less than 1 nanometer, it is called molecular dispersion, and the example are salt in water and sugar in water. Next, number 2 is colloidal dispersion. Colloidal dispersion has the size of 1 nanometer to 0.5 micrometer. Okay, and the example is milk, iron suspension, albumin and albumin nanoparticles. Next you will see coarse dispersion. Coarse dispersion is having the minimum size, and the size is more than 0.5 micron. No, molecular size is the minimum size, because nanometer is smaller than the micrometer. Okay, so this is coarse dispersion, and the size of the particle of coarse dispersion is more than 0.5 micron. Okay, examples are emulsion and suspension. Now we will see what are the composition of emulsions. Composition of emulsions. So they are oil, water, gum and other excipients. Oil, water, gum and other excipients. In this, the antioxidants and preservative are and flavoring agent are acting as the excipients. They are not having any pharmacological action. Okay, so antioxidant, preservative and flavoring agent, these will be considered under the excipients. And main part is the oil part and water part and gum part. Oil is the one phase, water is the another phase, when both the two phases are immiscible to each other, and the gum is the surfactant agent which will try to increase the solubility between the two phases. Next is cream. Cream is a viscous emulsion. So what are the types of emulsion? The types of emulsion. Types of emulsion based on the types of oil. Based on the types of oil: fixed oil emulsion, mineral oil emulsion, volatile oil emulsion, oleoresin oil. Fixed oil emulsion, volatile oil emulsion, mineral oil emulsion and oleoresin emulsion. Based on the globule size, you will see coarse emulsion, fine emulsion and micro emulsion. Based on the different phases, that is internal phase. So in the internal phase, if the internal phase is water or oil, if the internal phase is water, then it is called water in oil type emulsion. If the internal phase is oil, then it is called oil in water type emulsion. Next, based on the route of administration, if it is parenteral, then it is called parenteral emulsion, then ophthalmic emulsion and oral emulsion. Okay, next we will see the emulsions based on the type of oil. And what are the number of oils present and number of water and gum present in the emulsion, we will see that. Number one is fixed oil. So in the fixed oil emulsion, you will see 4 oils. See, fixed is starting with F, 4 is also starting with F. By this way you can remember 4 oil particles are present in the fixed oil emulsion. Water particle is 2 in every emulsion. All the types of emulsion having 2 water particles and 1 gum particles. How many gum? 1 gum. But they are having different number of oil particles. Okay, so in this we will see what are the different number of oil particles present in which type of emulsion. So number 1 is fixed oil emulsion. In fixed oil emulsion, you will see 4 oil particles. Again, in the mineral oil, you will see 3 oil particles. In the volatile oil, you will see 2 oil particles, and in the oleoresin oil, you will see 1 oil particles. Okay, so these are the male fern extract, oleoresin are the male fern extract, volatile oil are the turpentine oil. Example of volatile oil are turpentine oil, peppermint oil and cinnamon oil, and example of mineral oil are liquid paraffin. Example of mineral oil is liquid paraffin. Example of volatile oil is turpentine oil and peppermint oil and cinnamon oil. Example of oleoresin is male fern extract. Now, by which method these are produced? So the fixed oil emulsion is produced by using dry gum method and wet gum method. Next, mineral oil emulsion is produced by using bottle method, and next volatile oil is also prepared by using bottle method. Okay, Next we will see the different emulsion based on the globule size. Already we have seen earlier. So based on the globule size, there are three types. What are they? They are coarse emulsion, fine emulsion and micro emulsion. The size of coarse emulsion is between 0.1 to 100 micrometer, and the globule size of the fine emulsion is 0.25 to 2.5 micrometer, and the globule size of the micro emulsion is between 0.01 to 0.2 micrometer. Okay, so which one is the better, which one has the smaller size? This micro emulsion has the smaller size and the coarse emulsion has the larger size. So which one is better? This one is better. Next we will see the different characters of the emulsion. Okay, so number one character is globule size. So based on the globule size, emulsions are of three types. What are they? Coarse emulsion, fine emulsion and micro emulsion. And the size of globular 0. In the case of coarse emulsion it is 0.1 to 100 micrometer. In the case of fine emulsion it is 0.25 to 2.5 micrometer. In the case of micro emulsion it is 0.01 to 0.2 micrometer. Next, appearance. Appearance of coarse emulsion is milky. Appearance of fine emulsion is also milky. And appearance of micro emulsion is transparent. Why it is transparent? Because these particles or globules are very small in size. So because of that only these are transparent. Okay, next we will see the stability. Which one is more stable? The micro emulsion is more stable, and remaining coarse emulsion and fine emulsion are less stable, and micro emulsion is highly stable. So in this they will not ask which one is the less stable, they will simply ask which one is the high stable. So high stable is the micro emulsion. Next, concentration of the surfactant. So surfactant is in less concentration in the case of coarse and fine emulsion, but surfactant are more in the case of micro emulsion. Next we will see the formation. So this the coarse emulsion requires energy, fine emulsion also requires energy, but micro emulsion is spontaneous. Spontaneous means it doesn't require energy, it automatically forms, that is passively formation of micro emulsion takes place. Next, emulsion based on the internal phases. So what are the internal phases? See, internal phases are two types. One is disperse phase, one is disperse phase. There are two phases. The two phases are disperse phase and dispersion medium. In the disperse phase you will see two parts. One is water and one is solid. Water is in the case of emulsion and solid is in the case of suspension. But dispersion medium will be liquid in both the cases, either in the case of emulsion or in the case of suspension. Okay, now see, disperse phase is also called internal phase. It is also called discontinuous phase. I have mentioned earlier already. Dispersion medium is also called external phase. It is also called continuous phase. This I have mentioned earlier, all these 4 points. So disperse phase is also called internal phase. It is also called discontinuous phase. Dispersion medium is also called external phase. It is also called continuous phase. Okay, now see, if the disperse phase is water, then it is called water in oil type emulsion, and if the disperse phase is oil, then it is called oil in water type emulsion. If the disperse phase is oil, it is called oil in water type emulsion. If the disperse phase is water, then it is called water in oil type emulsion. Okay, so there are sometimes double emulsions are also possible. In that case, water in water type emulsion and oil in oil type emulsion. In that, what will happen? You will see 3 layers are there. So this is the middle layer, this is the outer layer. So sometimes it is oil in water in oil type emulsion, and also you will say water in oil in water type emulsion. So the middle one is oil, this one is water, this one is water, this one is oil, and here this one is oil, this one is oil, and this part is the water part. So water oil oil water oil type emulsion, or water oil water type emulsion. Okay, next, emulsion based on the route of administration. So number 1 is parenteral emulsion, which is taking place through the parenteral route, mainly by injections. Okay, next is oral emulsion, which is normally taken orally. Next is ophthalmic emulsion, which is used in the eyes. And next is cosmetic emulsion, which is normally used on the skin. That is, the skin has 3 layers: epidermis, dermis and hypodermis. Outer layer of the skin is called epidermis. Outer layer of the skin is called epidermis. Okay, and on this epidermis we will apply the emulsion here, and it will step by step, slowly it will go inside the skin. Okay, next, parenteral emulsion. So what is parenteral emulsion? These are fats. For examples are fat soluble vitamin. So what are the different types of vitamin? Vitamin A, vitamin. What are the example of fat soluble vitamin? Vitamin A, D, E, K. Vitamin A, D, E, K are the example of fat soluble vitamins. Okay. In this you will say vitamin A, vitamin E, vitamin K1, vitamin K2, vitamin K3, vitamin D1, D2, D3. All are the examples of fat soluble vitamin. Vitamin A is also called retinol, and the chemistry, that is organic name is beta adenone. Its main function is in the improvement of the vision. And okay.